continue talking about acids and bases today. We already talked about basic terminology, the three different definitions for acids and bases. We talked about some very simple properties of acids and bases. And what we're going to get into today is calculating pH, pOH, proton and hydroxide ion concentration. We'll finish that up probably next time, as well as learn how to name acids and bases, and then we'll get some good practice in there before we talk about titration next week. So we're going to introduce pH and pOH, and I'm sure you've seen a little bit of this in middle school. pH is an acidity scale, and it's going to give you an indication of how acidic a solution is. It can also be used to indicate basicity. pH stands for power of the hydrogen ion, and we know that a pH scale measures proton concentration. When you calculate pH, it's equal to negative log of the proton concentration. And in middle school, you learn that neutral pH has a pH of what? 7. So when it's below 7, when pH is less than 7, the solution is acidic. And be careful here, the lower the pH, the more acidity. So for example, if you have two solutions, one with a pH of 2 and one with a pH of 5, the solution with the pH of 2 is more acidic. Basicity. pH is going to be greater than 7 up to 14. You'll see here as the pH increases from above 7 to even greater, let's say 8, 9, 10, 11, 12, 13, 14, the basicity increases. So if, for example, you had two solutions, one with a pH of 9 and one with a pH of 13, which is more basic? The one with the pH of 13. Good. And that pH scale is shown here. Neutral, pH of 7, pH less than 7, acidic, pH greater than 7, basic. The lower the pH, the more acidic, the higher the pH, the more basic. And shown here is a very simple table showing you some common substances and their pHs. 0.1 molar hydrochloric acid, which you've used this year, has a pH of 1. Your stomach contents, which include hydrochloric acid, pH of about 2. When you have an upset stomach, you'll take an antacid, which is a base. That will help neutralize the acid in your stomach, and we'll talk about neutralization reactions later in the week. Vinegar has a pH of about 2.9. Vinegar contains the weak acid known as acetic acid. Soda for breakfast is a no-no. Soda is very acidic. It will eat away at your tummy if that's all you have for breakfast. Diet Coke is not the breakfast of champions, even though my husband really thinks it is. Grapes have a pH of about 4. Beer, which you are of course too young to drink, pH of about 4.5. Bread getting less acidic, if you will. Urine has a pH of about 6.6. Your saliva, as you would expect, would be neutral. Blood pH is critical for normal bodily processes. Blood has a pH of about 7.4. When blood pH drops, you can go into a condition known as acidosis. And if the acidity in your blood gets too high, a lot of processes may cease to function properly. Ammonia has a pH of about 11. You do a lot of cleaning with ammonia. If you want to clean earrings or jewelry, ammonia works really well. Sodium hydroxide has a pH of about 13 when its concentration is 0.1 molar. And we're going to learn how to determine pH from concentration right here. So again, lower pH, higher acidity, higher pH, higher basicity. So for example, sodium hydroxide at 0.1 molar would be more basic than ammonia at 0.1 molar. Excuse me. So we're going to learn how to calculate pH, power of the hydrogen ion, pOH, power of the hydroxide ion, proton concentration and hydroxide concentration, and we'll start with pH and pOH. Formulas to calculate pH and pOH, as well as their relationship, are shown here. pH is negative log of proton concentration. POH is negative log of hydroxide ion concentration, and the sum of the two is 14. If they give you proton concentration, it's very easy to find pH. If they give you hydroxide ion concentration, you'll find POH, and then subtract it from 14 to get the pH. If they give you an acid, and it's a strong acid, you can go right into that formula. If they give you a strong base, and it's a group 1 base, you can go right into this formula, and that's what we'll be looking at here. So just some simple examples, and several of you in here, not just several, at least 2 handfuls will be going into AP, where some of your math is non-calculator based. It's brain based. So I want to make sure you're comfortable figuring out pH, at least approximations, without a calculator. The first question, very straightforward. It says the proton concentration of a solution is 1 times 10 to the negative 4 molar. Calculate the pH of the solution. Is it acidic or basic? And explain your choice. So they've given us proton concentration. Those formulas will be provided to you on an assessment, so you don't need to memorize them. pH is negative log of proton concentration, so the negative log of 1.00 times 10 to the negative 4 molar, molar unit for concentration. If they give you a concentration that's 1 times 10 to a negative exponent, the pH will be the absolute value of that exponent. So that would be 4. The sig figs here are a little bit different than what you learned this year, so this will be a little bit tricky. You've got 3 sig figs here. Trailing zeros are significant if there's a decimal anywhere in that number. 3 sig figs. For sig figs for pH and POH, the sig figs start after the decimal point. So 4.000, 3 sig figs. So if the number is 1 times 10 to the negative power, the pH is equal to the absolute value of that exponent. This, of course, is an acidic solution because the pH is less than 7. If you are given a strong monoprotic acid, it only has 1 ionizable proton, and of your 8 strong acids, 7 of them are monoprotic. Just sulfuric acid is diprotic, and we're not going to play with that one, so you won't have to worry about it in regard to these type of calculations. You'll actually be titrating with it. For strong acids, the acid concentration will be equal to the proton concentration, because we know that strong acids ionize completely. So if the acid ionizes completely, then what you're going to see, for example, if you had nitric acid is one of the 8 strong acids. Strong acids ionize completely. So these reactions only go in the forward direction as opposed to the reversible reactions we've been looking at in the previous chapter. If you have a strong acid that's monoprotic, it only has 1 ionizable proton, you will see that these 2 concentrations are equal. So whatever the concentration of the strong acid will be the concentration of proton. So in this example shown here, they're telling you that nitric acid has a concentration of 3.2 times 10 to the negative 3 molar. And you want to calculate the pH of the solution, determine if it's acidic or basic, and explain. Nitric acid is a strong acid. I'll tell you it's a strong acid on the quiz. these two concentrations are equal. So the pH is the negative log of the proton concentration, negative log of 3.2 times 10 to the negative 3 molar. If this number is greater than 1 and less than 10, the pH will be 1 less than the absolute value of this number and some decimal. In addition, you have 2 sig figs here, 2 numbers after the decimal for pH. In regard to calculator usage, this will vary depending on the calculator you have. So for example, if you don't have a calculator on you, you will want to borrow one so that you're comfortable using your calculator. I'll help you use your calculator today, tomorrow, anytime you're doing classwork. But if you're taking a quiz or test, I can't walk you through how to use your calculator. So in your calculator, if you have the TI-30X2S, what you'll see here is you punch in exactly as it looks. Negative log 3.2 EE negative 3 equals, and you get 2.49. If you have the more simplistic TI-30, it may not look identical to this one, but the punch is the same. You would plug in the concentration, 3.2 EE negative 3, then hit log, and then hit the plus minus button. So make sure you are comfortable in regard to using your calculator. And with a pH of 2.49, the solution is clearly acidic because the pH is less than 7. Let's do a problem from scratch together. This is the next one in your notes. It says that the concentration of chloric acid, which is a strong acid, if you had a weak acid, it'd be very different. We're not going to get into it this year. 5.46 times 10 to the negative 2 molar. And I want to know the pH. Now this is a strong acid. It ionizes completely, so this is the concentration of proton. pH is equal to negative log of 5.46 times 10 to the negative 2 molar. This number is greater than 1 but less than 10, so the pH is going to be 1 point something. And in your calculator, go ahead and punch it. Make sure that you are comfortable with the plug-in process. Three sig figs after the decimal point for the pH here. And that's your pH. So if you're given proton concentration or given the concentration of a strong acid, pH is negative log of that concentration. Very straightforward. Where it can get a little bit tricky is in this next section. If given the concentration of hydroxide ion or the concentration of a strong group 1 base, you will need to get POH before pH because you'll have the concentration of hydroxide ion. So hydroxide ion concentration is 1 times 10 to the negative 2. We want to calculate the pH, determine if it's acidic or basic, and then explain. pOH is negative log of hydroxide ion concentration. Again, we have 1 times 10 to the negative 2. That's going to make the pOH 2. We have 3 sig figs here, 3 places after the decimal. pOH is 2.000. The sum of the two is 14. Maintain the number of decimal places in your pOH. 14 minus 2 gives you a pH of 12.000. Basic solution since the pH is greater than 7. Similarly to the way we worked with the strong acids, we'll work with the strong bases, but these can be a little trickier. Remember, your strong bases are going to be your group 1 hydroxides. For example, lithium hydroxide, sodium hydroxide, potassium hydroxide, etc. And some of the group 2 hydroxides, there's only 3: calcium hydroxide, barium hydroxide, and strontium hydroxide. Only these 3. All the group 1 hydroxides are strong bases. They will ionize completely. So if you had, for example, sodium hydroxide, it will ionize completely, and therefore the concentration of the strong base is equal to the concentration of hydroxide ion. You will need to be careful with those strong group 2 bases, and we'll get to them in just a minute. But if you look here, what's the mole ratio of strong base to hydroxide ion? 1 to 2, right? So these are 1 to 1, so their concentrations are equal. But this is a 1 to 2 mole ratio, so that's a little trickier. We'll take a look at that in a minute. Strong bases ionize completely. Concentration of a group 1 strong base, same concentration as hydroxide ion. Questions there? In looking at this example here, sodium hydroxide has a concentration in this example of 1.4 times 10 to the negative 3rd molar. Want to calculate the pH. Determine if it's acidic or basic. Explain. Why are these two concentrations the same? Sodium hydroxide is a strong base, and it therefore ionizes completely, 1 to 1 ratio of base to hydroxide ion. Why should we get the pOH first? Because sodium hydroxide is a base. So if you have a base, you're going to get hydroxide ion concentration first and pOH. So negative log of this is 2.85. How do you go from pOH to pH? Subtract from 14. Here's your pH. And this would be a basic solution because the pH is greater than 7. Let's take a look at this problem and work it together. It says the concentration of cesium hydroxide is 2.4 times 10 to the negative 4 molar. Why is that equal to the concentration of hydroxide ion? This is a strong Base, base. Does it ionize completely? Yes. Same concentration. So are you going to get the pH first or the POH? POH. And POH is equal to negative log of the concentration. And that's going to be 3 point something something. So that's the POH. How do I get the pH? 14 minus that? Is that an acid or a base? Base, because the pH is? Good. Yes, yes? All right, let's make it harder. Ever so slightly. And then we'll integrate several concepts that we've already learned. In the next example, I've given you calcium hydroxide concentration. What's different about calcium hydroxide than sodium hydroxide or lithium hydroxide? It's not a 1-to-1 ratio. You're going to have 1 mole of base to 2 moles of hydroxide ion. So that's the only tricky part. We're going to calculate pH, figure out if it's acidic or basic. Check out the 1 to 2 mole ratio here. So is the concentration of base equal to the concentration of hydroxide ion? No, it isn't. So here comes stoichiometry, which you have mastered and you love.
That was like a year ago.
For every 1 mole of base, we have 2 moles of hydroxide ion. So you have a 1 to 2 mole ratio here. So if you have 1.4 times 10 to the negative third molar calcium hydroxide, you have 2.8 times 10 to the negative third molar hydroxide ion. Once you get that, it's exactly as you did previously. Why should I use POH before pH in this problem? Because you were given a base and you now have the hydroxide ion concentration. So POH is negative log of this. Negative log of that is 2.55. How do you go from POH to pH? 14 minus this is 11.45. Why is this solution basic? pH is greater than 7. You want to do this one together or you want to try? Together, together, together. Together forever. Here we go. Here we go. It's from Elmo in Grouchland.
It's from the Thunder Moon.
It's the Thunder Moon.
It's the Thunder Moon.
Alrighty, let's get back on track. Strontium hydroxide concentration given. We want to know the pH and then we'll analyze it. What do we do?
Multiply. Mole ratio.
Mole ratio.
Really?
For every 1 mole of strontium hydroxide,
There's 2 moles of OH.
now please don't memorize and say, oh, I always multiply by 2, because we're going to do some problems later on where you're dividing. So look at the stoichiometry. So the concentration of hydroxide ion then is 4.6 times 10 to the negative 2 molar. What's your next step? Negative log to get the POH.
And then subtract.
You guys are too fast.
We're too good. What is it? When do you use it? When do you just speed it up? Come on.
Maybe 7th period just isn't as good.
Hey, hey, hey.
I'll go out.
And then the pH is 14 minus that.
Put on 0.25 speed.
Alrighty? And this would be a basic solution. Why? Not it.
The pH is greater than 7.
Alrighty.
Because something is so.
Basic solution because pH is greater than 7.
Wait,
I have pretty handwriting.
no,
Alrighty.
abbreviate solution is SOLN.
Yeah, I guess yeah.
Here you go.
There. Well, I know BC stands for because.
Because he's hit with the kids.
Alright. So, you know how to calculate pH from proton concentration or a strong acid. You know how to calculate POH from hydroxide ion or a strong group 1 or group 2 base. So now we want to see if you remember some solution chemistry.
Oh.
Oh my. So,
No.
Wait, we're supposed to remember the rest of the
you're supposed to remember everything.
I don't even know what a mole is.
page.
What is molarity equal to?
Moles, solutes, or volume, liter,
Oh, yeah.
I already said that, Will.
It
You
has to
got
be
it.
later.
Moles of solute over the total volume of solution in liters, right? So,
Oh my god.
if you were given the mass of a substance and the volume of solution, could you get the molarity?
Yes.
Sure you could. And once you had the molarity of the acid or base, you now know how to get pH, correct?
Yeah.
So let's see if you can work through these problems. It says 0.371 grams of nitric acid are dissolved in a final volume of 751 mils of solution. Calculate the pH and do the same analysis we've been talking about. Let's get the information down and see if we can get it to rip. The mass of nitric acid is 0.371 grams. And the total volume is 751 mils. We want the pH. What do? First thing we're going to do is go grams to moles and mils to liters. Whatever rocks your world first is fine. Here's your liters, moving the decimal 3 to the left. And we're going to convert this to moles. 1 mole and this will be your molecular mass. You've got a hydrogen, a nitrogen, and 3 oxygens, and that will be 63.0119 grams. We'll flip and multiply. I'm going to write this over here. That's going to be 5.89 times 10 to the negative third moles. And then to get the concentration, we're going to divide that by what? Liters, right? And so the concentration of this strong acid is 7.84 times 10 to the negative third molar. Once you have the concentration, how do you get the pH? Because this is equal to proton concentration. It's a strong acid. It ionizes completely. pH will be negative log of that proton concentration. And that's going to be 2.106. I would like you to try number 7. It's grossly similar. See if you can get it to rip. It means it's almost identical.
Alright, that's what I'm thinking.
Are you done? Are you done? I was just kidding.
That was a good joke.
Well, I heard talking.
Negative log. Negative log.
All right, how'd we do?
Great, I did great.
Dang it.
Steven, what'd you get?
Number.
I got like
A pH.
it's definitely acidic.
It's definitely acid.
How many moles did you get?
Wait a minute.
Okay.
It's a number.
I don't know.
Whatever the mass of HCl is divided by its ion.
It's about 14 moles.
Who got what I got?
I did.
I got exactly that.
That's
Don't
what
look
I
if
got.
you're not ready.
Gavin.
That's what I got.
Gavin. About 14, yeah. I got exactly that. I too got a big calculator.
Negative log.
Did you get it?
Yes.
Yes? Easy peasy?
Too easy.
You're going to see one of these worth a lot of points on your Quizzy Wizzy. All right. Couple last things I want to show you for the day. And then you can practice with lots of homework.
Yes.
Okay, just a smidgy of homework. Alrighty. Last thing we want to talk about today, and then we'll link all the pieces together next time. We want to be able to calculate proton and hydroxide ion concentration. So we know you get pH by doing negative log of proton concentration. And you get POH by doing negative log of hydroxide ion concentration. So you go backwards. Now back in the good old days, when I went to school, we called it anti-log. But I think you guys are just doing 10 to the x now. If you want the inverse of the log, you're doing 10 to the x, right?
Why don't you just do the
Take a look at your calculator for a sec. So you're just doing second log, right? 10 to the x?
Yeah.
Okay. We learned it as anti-log. I gotta ask Mr. Marr. I bet you he learned it as anti-log too. Alrighty, let's take a look. Two easy formulas highlighted in green. If you want to calculate proton concentration, you do 10 to the negative pH. If you want hydroxide ion concentration, you do 10 to the negative POH. The product of the two is actually 1 times 10 to the negative 14, which is the water ionization constant. We're not going to get into kW this year, but the formulas highlighted in green are fair game. Look how easy. It says a solution has a pH of 3.45. If you wanted to calculate proton concentration, you would just do 10 to the negative pH, which is 10 to the negative 3.45. Proton concentration, now be careful with siggy wiggies. pH, 2 sig figs, they're after the decimal. 2 sig figs here. Note the unit for concentration. Capital M for molarity, moles per liter.
Why is it 2 sig figs?
Because you have 2 sig figs after the decimal and the pH.
Is that a negative 3?
Yes. You want me to make it bigger?
Yes.
Here, look. Can you see now? That's a negative right there.
I see.
All right. If you are given POH, there are 2 ways to do it. We're going to focus on this nice, easy way here. How do you get pH from POH? You subtract the POH from 14, right? So here's the pH, 10 to the negative pH, 3 sig figs in the pH, 1.76 times 10 to the negative 13, capital M, unit of concentration.
How are you getting that number?
Okay, so in your calculator, here, 2 ways to go. I'm going to do the first one first, where it said 10 to the negative 3.45. Ready? You're going to do, on my calculator, it's second log, so it's 10 to the x, and then minus, or the negative button, 3.45 equals. Now, if you want to put it in scientific notation, you can. Second psi, move it to psi, hit enter, and you've got it in scientific notation. 3.5 times 10 to the negative 4. If you have this calculator or the simplified TI-30, which I think a lot of you did purchase last year in geometry, you're going to put in 3.45, hit the plus minus button, and then the 10 to the x button. It should be second log, and you've got it. And you can put it in scientific notation if you want. On some of your calculators, your scientific notation is probably second 5. Mine looks like it's second. Oh, no. I made boo-boo.
Mine is second, wherever I see it says
Oh, because mine is funkier. Mine's that one. There it is. Mine was third, but this calculator is a little different. Do you want me to put one of yours under the screen?
Sure, I got you.
You got me? Hook me up. Throw, let's go.
Wow.
This was just easier to grab, I'm sorry.
Yeah, because it was mine.
All right, on this one,
Yeah.
3.45, hit that plus minus button, second log. And if you want it in scientific notation, hit second 5. And if you want it out, hit second 4. Second 5 in, second 5 out. Here you go. Hayla, make sure you can do it.
I know.
Thank you so much.
Thank you so much.
All right, let's try a bunch together and we'll call it a day.
Sounds good.
Here we go. Number 3. We'll do the first 2 together and you'll do the next one yourself. pH on this is 3.54. We want to calculate proton concentration. 10 to the negative pH. 10 to the negative 3.54. Let's all do it and see what we get.
2.88.
Now watch the Siggy Wigs. 2 sig figs. 2.9 times 10 to the negative 4. What's my unit? On number 4, you have this in your notes, so you don't need to rewrite it. Now be careful. This one's mean. Right, so they gave me the POH, so what do I need to get first? The pH. 14 minus that. 10 to the negative. 2 Siggy Wiggies.
30.72 to the 10 to the negative 9.
Uh-oh. Now 2 Siggy Wiggies. This one's a little bit tricky.
That's not incorrect.
Well, you guys looked initially out of your calculator. You have something like this, right?
4.9.
But you want 2 sigs, and you've got a 9 followed by a 5. Odd number followed by 5. Round up. So that rounds, that rounds. Boom. Try number 5. It says pH is 12.40. And I want proton.
So you got to subtract.
No, you don't.
No.
This one's easy. You don't have to subtract because they didn't give you POH. But I'll do a nice tricky wiki one with you. So what'd you get for this? 4.0 times 10 to the negative 13. What's the unit? Molar. So what if I did this? This would be mean. What if I gave you this pH here? We'll just make like a new problem. What if I said that the pH was 8.03 and I asked you for this? Ooh. Ooh. Then we'd have to get this, right? So what's that? And then this would be this, right? So what's your answer? Who's got it? Who's got it? No.
1.1 times 10 to the negative 6 molar.
Ooh, try hard.
That's good.
Oh, yes. What a sweat.
What's the
1.1. Yeah, but how's 10 to the negative 6
pretty
molar?
good? 4 in a row.
How many balloons you got?
3. I do that under pressure.
All right, next time we're going to continue to link molarity in here so you can see how the two really fit together.
I can't wait.
I know you can't wait. And we're also, guys, we're not done yet. We're also going going to learn how to name acids, which once you are shown will be very easy for you. On your classwork, which you already have, you should have completed 1 through 10 already. And if you really want to be ready for tomorrow, you'll do through number 19.
What day is tomorrow?
For sure.
Any questions?
No.
All right, so we did pH, pOH, proton, hydroxide, and concentration.